The objective of this practical is to construct a half-wave rectifier and to analyze its output. Okay, now this is the circuit diagram. Okay, as you can see here, we have function generator, oscilloscope, practical diode and a load resistor. Now how I am going to build this circuit on a breadboard unit. Now as you can see here, I have connected this diode randomly on this breadboard. Now I am going to connect resistor. As you can see here, resistor is connected in series with this diode. So now the resistor is connected like this. Okay, now again look at this circuit diagram. As you can see here, input is coming from function generator and we are going to observe the output signal on oscilloscope. Okay, it means now input is given like this. It means here I have connected this jumper wire. Okay, now I'm going to connect this jumper wire with the positive terminal coming from function generator. Now what about output? As you can see here, output voltage appears across load resistor, so it means we have to connect terminals of oscilloscope in parallel to this load resistor like this. It means the black jumper wire is going to be connected to the positive terminal of oscilloscope, and this brown jumper wire, we have to connect this wire to the negative terminal of the oscilloscope. The input signal is given through this function generator. As you can see here, I have set the waveform to sine wave. Frequency is 1 kilohertz and amplitude is 10 volts peak to peak. As you can see here, this function generator is now connected to this oscilloscope. It means I am observing this input signal on this oscilloscope. Now here I have pressed cursor and stop button. Okay, as you can see here, we are getting these readings. Okay, now how I am going to measure different parameters like peak to peak voltage and high and minimum values of voltages. Okay, for this I am going to select this measure button. Okay, now after pressing this measure button, you will get something like this. Okay, now I am going to use this variable knob. Okay, and when I am rotating this knob, as you can see here, it is giving me different options. Okay, now I can select that option which I want to know. Okay, now if I want to know amplitude of this waveform, I set this knob here and now I'm going to press this select button. Okay, now it will give me amplitude. As you can see here, we are getting this amplitude. Okay, now what about high and low values? Again I'll rotate this knob. Okay, and here I'm selecting this value. Okay, and now as you can see, you are getting this parameter value as well. Okay, now what about mean? Again I'm selecting this parameter and as you can see here, I'm getting the value of mean. Okay, so this is how you are going to observe different parameters of this waveform. Now in order to observe the output signal, I have connected the function generator and oscilloscope to this circuit like this. As you can see here, the probes of function generator are connected like this. It means here the positive terminal of the function generator is connected to the positive terminal of this diode, and here the negative terminal is connected like this, because as you can see here, the second terminal of resistor and the second terminal of function generator and oscilloscope, they are connected to each other and they are grounded. Okay, so we have connected these terminals like this. Okay, and here as you can see, the positive terminal of this oscilloscope is connected to first terminal of load resistor. Okay, with the help of this black jumper wire. Now after making these connections, an output waveform will appear on the oscilloscope. Now after making all those connections and pressing the auto set button on the oscilloscope, you will get an output waveform like this. Okay, now again you will press that measure button on the oscilloscope for observing these required parameters. Okay, and then you are going to fill this table and then you will perform these calculations. Okay, after that you will draw input and output waveforms like this. Okay, so this was your lab 8.